Hi guys, today I would like to discuss a new concept of electric field. To know much more about electric field, I would like to recall two important concept. One is the concept of force. We already know what is a force. Force is nothing but an action, pulling or pushing, and types of forces. According to definition, forces are two types. The first type is contact force. In contact force, the object should interact each other. So these are the examples for contact force. If there is no contact between two objects, so the force would not exert on each other. Such type of forces are known as contact forces. Force due to spring should contact, and drag viscous force should contact, and frictional you should contact force, and above all normal reaction force it is also should contact. And another type of force which are known as non-contact forces. Non-contact forces means by definition itself there is no need for interaction between the objects. All natural forces, electromagnetic force or electric force and gravitational force and nuclear force, so these all comes under non-contact forces. Newton wondered about his gravitational force, how a gravitational force acts without contact. Yeah, obviously gravitational force is a non-contact force. Similarly, magnetism it is also non-contact force, and electrical charges. Now we are learning about the electrical charges, the force between charges. So there is no need of contact. So this force comes under the non-contact forces. To explain these non-contact forces, especially these electric forces, Michael Faraday, a British physicist, introduced the concept of field. Michael Faraday introduced the concept of field. According to his words, an electric field extends outward from every charge. So these are his words to explaining about what is force, what is field. First of all, electric field extends outward from every charge and permits all space. So to understand this, I would like to give certain analogy. The analogy is that suppose we are in the class. If I come to class by applying perfume, if I apply perfume, the fragrance of the perfume will spread all over the class. Yeah. So the fragrance is coming from me. Now I became the source of that fragrance. Similarly, if you take same analogy at here, every charge extend outwards electric field in all over the space. Now, how would I know that electric field is exist? To know electric field is exist, now here we need to bring a second charge called Q2 is placed near to the first charge. If you can place near to the first charge, it feels a force. It means second charge feels a force. Now that force is exerted by the electric field that is there. The electric field is there due to because of the source charge. Okay. So by seeing this small diagram, here Q is the source charge and these lines will represent the electric field. So these lines will be extended three-dimensionally all over the space up to infinite. Now, if I bring at point P some test charge, now the test charge at point P will experience a force. That force is due to because the electric field of this source charge. So this electric field, the concept of the electric field is applied to each and every charge. So this is the concept of the field which made us to understand better, and this field concept will apply all gravitational field, almost on all natural forces, to understand how these charges or masses get interact even though these charges are the far away. Now if we can see, even though they are in the far away, they started to exert a force on each other because the field of the source charge will be extended up to infinity. I would like to show the concept of electric field with the help of PHET stimulation. Suppose I am having it here positive charge and negative charge. If I took 1 nanocoulomb positive charge at here, now because of this positive charge right at here, all over the space, electric field is existing. How would I know? With the help of sensors, suppose if I bring a sensor on this free space at here, now this, if you take as a test charge, I am changing the names for a moment. I will follow this notation for rest of the course. This single charge which I have taken, I call as source charge, and the one which I kept it here, so this I will take as a test charge. Now if you place this test charge in the vicinity of this charge anywhere, depends upon the position. So this test charge will experience a force. Here the red arrow mark shows the direction of the force and the length of the arrow mark shows the magnitude of the force. This is the vector notation. Suppose if you bring close to this source charge, according to Coulomb's law, force is inversely proportional to distance between them. Automatically the force will increases. So that is the proof. The strength, the length of the arrow mark is increasing. Suppose if you move away from the source charge, if you see, the strength of the arrow mark is decreasing. If you take as many as you can, so everywhere everywhere there is something is existing. So that something we named as electric field. Electric field is always exist. It comes with the charge. So if I want to check the Coulomb's law, I want to check the Coulomb's law. So I have taken one is a source charge, another one is a test charge. So because of these two charges, there is a force acting between them. Coulomb's law says force is directly proportional to product of the charge. It means if you increase the strength of the charge, magnitude of the charge, so I am increasing now 3 nanocoulomb. So the force at this point is increasing. So that is the length of the arrow mark shows. And Coulomb's law also says that the force is inversely proportional to distance. It means if you can decrease the distance, you see the length of the arrow mark is increasing, and vice versa. If you increase the distance, the force is also decreases. So how this charge is experiencing that force? Because of this source charge in this vicinity of three-dimensional space, there is something existing. So that is known as electric field. So that's the concept of electric field. We can define electric field as the electrostatic force per unit test charge, which is acting on vanishingly small positive charge placed at given point. So electric field E equal to force per electric field E equal to force per charge. So this is the formula for electric field. So this is the force. Which force? We are still not talking about only Coulomb force per charge. So for that I need two things. One is known as source charge. So let me take this positive, it becomes my plus capital Q, which I can call as source charge. According to Faraday, so because of this source charge, everywhere electric field exists. To know that, I wish I bring a very small, tiny positive charge, small q. Why this is so small? Because this charge is also having electric field. I would like to find the electric field due to because of the source charge, and since it is also positive charge, it is also existing electric field, and this electric field should not disturb the electric field of this source charge. Yeah, this is for as a theoretical purpose. So that's why we have taken a very tiny, very small positive charge, so that charge should not disturb the electric field of the source charge. So this small charge we are calling as test charge. So this is a notation which I used to follow further. So they are separated at a distance of small r. I would like to calculate the electric field at here. For that, first I need to write the force F equal to K times Q, capital Q, and small q by the distance r square. And here the charge, force per charge, precisely if you can say this is the test charge. According to definition, electric field equal to force per test charge. So here the value of the force is here, the test charge, here the test charge is equal to Q. Now calculate the electric field E equal to force quantity K times Q, small q, by R square divided by test charge. Test charge value goes to small q. Now the test charge will be cancelled. The formula is left over with electric field is equal to K times Q by R square. So the electric field now contains K, Coulomb's constant, and the magnitude of the source charge divided by R square. R is the distance where you wish to find the electric field. So finally, the electric field E equal to force per test charge. Now you write the electric field units. The electric field units are SI unit is force units are the Newton, and the charge units are the Coulomb. So you can write Newton Coulomb inverse. And the dimensional formula is electric field dimensional formula. You can write the force dimensional formula. It is the force per charge, test charge. Force dimensional formula MLT inverse by charge dimensional coulombs. These coulombs you can convert as current ampere times T. T is the time. So if you can do that, you will reach that the Coulomb's constant, the dimensional formula for electric force is E equal to MLT inverse, that is the force dimension, divided by Coulomb dimensions, ampere times second T, so which equal to MLA inverse and the T inverse 2. So this will becomes the dimensional formula for electric field. So that's all about the electric field. Electric field is defined as simplest the electric force per unit test charge, which gives the strength of the electric field at a given point. What is the importance of electric field? Since electric field E equal to force per test charge, it is the easiest way to find the force. It means if you know the electric field, so in symbolic form I would like to write electric field equal to F by Q. So this formula you remember. So electric field is E equal to force per test charge, F by Q. If you can rearrange this formula, force F equal to electric field times Q. So this is the another formula to calculate the force. If you know the electric field and the source test charge, if you know the electric field and the test charge, it is easy to calculate the force because of the source charge. So that is the importance of the electric field. Now here no need to apply the Coulomb's force again and again. Just if you know the value of the electric field at a given point, it is there everywhere nearby the vicinity of the source charge. If you place a test charge nearer to that, we will find out the force. In the coming concept, we will understand how to find the electric field between the charges. Let's see the first concept in the electric field. Electric field due to a point charge. For that, consider a point charge which I call as source. So here I am taking as source as capital small q. Consider a source charge which is small q. Okay. Now I would like to find electric field at a given point P at here, which is at a distance r from the source charge. Repeating again, I would like to find the electric field because of this source charge at a point P, which is at a distance of small r. Further, I need a help of another charge. I would bring a tiny small charge which I would like to call Q naught, and I will place at point P. Since they both are positive charge, so there is a force. The force is along in this direction. It's only the direction, not the magnitude. There is a force between the Q and the Q naught at this point P. To calculate electric field at point P, so I'm having only one formula. The formula is force per test charge. Now write the force, Coulomb force between the two charges. Coulomb force F between the two charges equal to K times Q naught by R square. And here the test charge magnitude equal to Q naught. Now you substitute these two values in the above equation and you can get the force F equal to K times Q naught by R square divided by the magnitude of the test charge equal to Q naught. So the test charge gets cancelled. You will end up the electric field at a point P equal to K times the magnitude of the Q and R square. So the formula for electric field equal to K Q by R square. Here the K is the Coulomb's constant, Q is the magnitude of the source charge, and R is the distance where you would like to find the electric field. So from the above equation, I can write electric field is directly proportional to magnitude of the source charge. Electric field is directly proportional to magnitude of source charge, and electric field is inversely proportional to square of distance between them. So these two affect the strength of the electric field at a given point you would like to know. So this is the concept of the electric field due to a point charge. So in the next concept, I would like to see the electric field due to because of the multiple charges at a given point. So this is that is also same concept, just like force due to because of multiple charges.